Hi, my name is Brandon Jank. I am a computer science undergraduate at the University of Idaho. Today I'll be presenting an introduction to fused deposition modeling, also known as FDM. FDM is a 3D printing process that utilizes plastic wire called filament to create 3D objects. You can think of this process as a hot glue gun that is controlled by a robot. There are multitudes of materials available for 3D printing. The most common material used for FDM is PLA or ABS. Polylactic acid is made from sugar and is also biodegradable. Acrylonitrile butadiene styrene or ABS is made from petroleum products but is stronger and more flexible than PLA. Wood can also be used for 3D printing. Fine wood powder is mixed with a plastic binder to create wood filament. All of these materials are wound into a continuous spool of filament, and this filament is usually 1.75 millimeters in diameter, and each one of these spools usually contain about a kilogram of material. This brings us to the extruder. The extruder takes filament from the spool and heats it for deposition onto the object being printed. It consists of a hot end and a cold end. The hot end being towards the bottom where it's heated to come out of the nozzle, and the cold end that's at the top, which forces the filament down into the hot end. The operation of the extruder is covered much more detail in the extended technical description flyer. The build plate supports the object while it is being printed. The printer moves the extruder and the build plate at the same time to form an object, kind of like an Etch-a-Sketch. Molten plastic comes out of the nozzle and is deposited onto the build plate or the previous layer. After each layer, the print head moves slightly upward to get ready to print the next layer. Combining the filament, extruder, and build plate, we finally have all the parts for a working FDM printer. This video shows my 3D printer creating a 3-axis helical gear. Note that each frame of the video is just one slice or layer of the object. I hope you've enjoyed this quick introduction to fused deposition modeling. This is Brandon Jank signing off, and I thank you for watching.